Every morning, billions of people do the same thing. They wake up, reach for a smartphone, unlock it, and enter a world of instant information. Messages, maps, banking, artificial intelligence, video, social media. It all feels normal. But hidden inside that device is something most of us never think about. A piece of technology smaller than your fingernail. A semiconductor chip. And that tiny object is now one of the most important technologies on Earth. In fact, the entire global semiconductor industry generated almost $800 billion in sales in 2025. And the industry is still growing rapidly. So how did something so small become the foundation of the modern world? And what would happen if we suddenly couldn't make these chips anymore? Let's find out. Look around a modern city. Cars move through traffic, elevators carry millions of people, hospitals operate sophisticated machines, banks process transactions, airports coordinate thousands of passengers, data centers run services used by billions of people. And behind almost every one of these systems is a semiconductor. Chips aren't only inside smartphones and computers, they are inside cars, industrial machines, communication systems, satellites, medical equipment, and countless everyday devices. That's why the semiconductor industry is so much bigger than the technology inside your pocket. According to the World Semiconductor Trade Statistics Organization, global semiconductor sales reached approximately $795.6 billion in 2025. That's an increase of more than 26% in just 1 year. And one of the biggest reasons for that growth is the explosion in computing and artificial intelligence. The world isn't simply buying more electronics, it is demanding more computing power than ever before. But what exactly is a chip? At its most basic level, a semiconductor chip is a tiny piece of material, usually silicon, containing enormous numbers of electronic components. The most important of these components are transistors. Think of a transistor as a microscopic switch. It can represent electrical states that computers use to process information. One transistor doesn't sound impressive, but modern chips don't contain one. They contain billions. And that is where the real revolution happened. Humanity learned how to put more and more transistors into smaller and smaller spaces. The result was extraordinary. Computers became faster, phones became smaller, cars became smarter, and machines gained the ability to process enormous amounts of information. The modern digital world was essentially built on one simple idea: make the electronic switch smaller and put more of them together. But this wasn't how computing started. Early electronic computers relied on vacuum tubes. These components were enormous compared with today's transistors. They consumed large amounts of electricity. They produced heat, and they were much less practical for building small, reliable machines. Then came a breakthrough. In 1947, researchers at Bell Labs demonstrated the transistor. It was smaller, more efficient, and far more suitable for the future of electronics. The transistor didn't immediately create the smartphone, but it created something much more important: a path toward miniaturization. And once engineers learned how to manufacture these components at scale, the race toward smaller and more powerful electronics had begun. Over the following decades, engineers kept asking the same question: how many transistors can we fit onto one piece of silicon? The answer kept increasing. This trend transformed the economics of computing. A machine that once required an entire room could eventually fit on a desk, then on a lap, then inside a pocket, and eventually inside devices small enough to wear on your wrist. This is why the history of semiconductors is really a history of miniaturization. But there was another breakthrough. Instead of connecting individual components manually, engineers learned to manufacture huge numbers of them together on a single piece of silicon. That became the foundation of the integrated circuit. And from there, the semiconductor industry exploded. Today, manufacturing an advanced chip is one of the most complicated industrial processes on Earth. The process starts with extremely pure silicon. Engineers create thin silicon wafers. Then they repeatedly deposit, pattern, etch, and modify microscopic layers. The goal is to build incredibly complex electronic structures on the surface of the wafer. And the scale is almost difficult to imagine. Features are measured in nanometers. A nanometer is 1/1,000,000th of a meter. At these dimensions, microscopic contamination can become a serious problem. That's why semiconductor factories, known as fabs, are highly controlled environments. And building the capability to manufacture advanced chips requires enormous investment. This is not a business where you simply buy a machine and start producing. It requires specialized equipment, engineering expertise, materials, software, enormous amounts of capital, and years of experience. And this is where the semiconductor story becomes even more interesting. The companies that design chips are not necessarily the companies that manufacture them. One of the most important manufacturers in the world is Taiwan Semiconductor Manufacturing Company, better known as TSMC. TSMC operates one of the world's most advanced semiconductor manufacturing networks. In 2025, TSMC reported that 74% of its wafer revenue came from advanced technologies defined as 7 nanometer and smaller, and its 3 nanometer technology alone represented 24% of total wafer revenue. These numbers tell us something important. The leading edge of semiconductor manufacturing is not just about making chips. It is about making them smaller, more powerful, and more energy efficient. And the demand is enormous. TSMC's revenue increased by 35.9% in U.S. dollar terms in 2025, according to its annual report. The company also said AI-related demand remained particularly strong. In other words, the tiny chip inside your devices has become part of a gigantic global industrial system. Now let's bring this back to something familiar. Your smartphone. Inside it are multiple chips performing different jobs. One handles processing, another may manage wireless communication. Others control power, cameras, memory, and other functions. And these chips have to perform all of this while consuming very little energy. That's one reason smartphone technology has advanced so quickly. The computing power available inside a device you can hold in one hand would have been unimaginable to earlier generations. But smartphones are only one part of the story, because the next major consumer of advanced chips is something much bigger: the automobile. Modern cars are increasingly becoming computers on wheels. A single vehicle can contain dozens of electronic control systems. They manage everything from engine functions and braking to cameras, navigation, entertainment, and driver assistance. Electric vehicles take this even further, and as vehicles become more autonomous, the amount of computing required inside them continues to increase. This creates another enormous source of semiconductor demand. And remember, we haven't even reached the biggest chip consumer of the current technological revolution yet. That consumer is artificial intelligence. Training and running advanced AI systems requires enormous amounts of computing power, and that means enormous numbers of specialized processors. This is where companies such as NVIDIA became central to the AI boom. NVIDIA's fiscal 2026 revenue reached $215.9 billion, an increase of 65% from the previous year. But the most striking number was its data center business. In the fourth quarter of fiscal 2026 alone, NVIDIA reported $62.3 billion in data center revenue. That was up 75% from a year earlier. These numbers show just how rapidly AI infrastructure has become a massive industry. The AI revolution isn't happening only inside software. Behind every AI model is physical infrastructure, servers, networking equipment, memory, cooling, electricity. And at the heart of it all, semiconductors. And AI is changing what we expect from chips. Traditional processors were designed for general computing. AI workloads often require enormous amounts of parallel computation. That's why specialized accelerators and GPUs have become so important. But even the most powerful processor is useless without memory, networking, and advanced packaging. The semiconductor industry is therefore becoming an ecosystem of specialized technologies working together, and demand is growing across the entire system. In the first quarter of 2026, global semiconductor sales reached $298.5 billion, according to the Semiconductor Industry Association. That was 25% higher than the previous quarter. The industry is now moving toward a remarkable milestone: $1 trillion in annual semiconductor sales. A technology once invisible to most people is becoming one of the world's largest industrial markets, and chips don't stop at Earth. Satellites depend on specialized electronics to communicate, navigate, process data, and operate in extreme environments. Spacecraft need computers that can survive radiation, temperature changes, and years without physical maintenance. So when we talk about semiconductors, we're not talking only about smartphones and laptops. We're talking about the infrastructure that allows modern civilization to communicate across continents, and sometimes across planets. But there is an even more serious reason governments care about semiconductor technology. Military technology also depends heavily on advanced electronics, radar systems, communication equipment, guidance systems, satellites, drones, sensors, electronic warfare. All require computing and semiconductor technology. This is one reason semiconductor supply chains have become a strategic issue for governments. The technology is economically valuable, but it is also strategically important. And that creates a problem, because the semiconductor supply chain is global. The design of a chip might happen in one country. The equipment used to manufacture it might come from another. The chip could be fabricated somewhere else, and the final product could be assembled on another continent. The modern chip is therefore the result of a global technological network. Think about how unusual that is. A smartphone may contain technology developed across several countries. The semiconductor manufacturing equipment itself is highly specialized. ASML, a Dutch company, is a critical supplier of advanced lithography systems used in leading-edge chip manufacturing. In 2025, ASML generated 32.7 billion euros in sales and spent 4.7 billion euros on research and development. Its EUV lithography technology plays a crucial role in manufacturing some of the world's most advanced chips. So the semiconductor isn't really a single product. It's a global ecosystem. Designers, equipment manufacturers, material suppliers, chip foundries, packaging companies, cloud providers, and finally, the devices and services that billions of people use every day. Break one important part of that chain, and the effects can spread across the world. So let's return to the beginning. A tiny piece of silicon, something you can barely see. Yet inside it are billions of microscopic components. Together, they perform calculations that control machines, process information, and power the digital systems of modern civilization. In 2025, the global semiconductor market approached $800 billion. In early 2026, quarterly sales continued to surge. Artificial intelligence is pushing demand even higher, and companies across the world are investing billions to secure the computing power of the future. So the next time you hold a smartphone, don't just see a phone. Look at the tiny piece of silicon inside it, because that tiny chip represents something much bigger. It represents decades of science, billions of dollars of investment, thousands of engineers, a global supply chain. and one of humanity's greatest technological achievements, the ability to make incredibly powerful machines from something almost impossibly small. The world runs on technology, and technology runs on chips. This is Quantum Mind, stories that explain our world. Subscribe for the next story.